Hi guys. So before you start watching, remember that you watched that video, How Big is a Mole? Because I'm going to be referencing some things in there. And so we're going to be watching two more videos. This one is called Mole Video Particles, and then the next one is going to be Mole Video Mass. All right, so hopefully what you remember from that video is that if you have 1 mole of something, you have 6.02 times 10 to the 23rd of those somethings. Just like if you have 1 dozen of something, you have 12 of those somethings. Okay, 1 dozen donuts means you have 12 donuts. 1 mole of donuts, 6.02 times 10 to the 23rd donuts. Okay, so you're familiar with the counting unit of dozen. Now that you're a chemist, you have to become familiar with the counting unit of a mole. Now, hopefully you also remember from that video that the reason why we have to have such a ginormous number, 6.02 with 23 zeros, is because our atoms and our molecules are so very, 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 very small that we need to have that many of them so that we can actually see them, handle them, work with them. Okay, so I kept saying if I have 1 mole of something. So what we need to do now is we need to make sure instead of using the word 1 mole of something, that we use the appropriate particle type when we're referencing a chemical substance. So you guys may recall from our matter pyramid unit that some substances exist as atoms and some substances exist as molecules. Now, it turns out that there is a third type of thing, particle, that certain substances exist as. We haven't learned about those yet. Those are what are referred to as formula units. Okay, so if I have 1 mole of sodium chloride, how am I supposed to know if it exists as atoms, molecules, or formula units? Well, let's do a quick review. So things that exist as atoms, these are going to be our non-diatomic elements. So in other words, not the 7-Ups or the Brinkelhoffs. I hope you remember those 7-Ups and those Brinkelhoffs. So if I were to have, for example, 1 mole of carbon, because it's a non-diatomic element, therefore I have 6.02 times 10 to the 23rd atoms of carbon. Now, if you're wondering why I chopped off the letter E at the end of that word mole there, it's because that is what a standard abbreviation for the word mole is, just to drop that E. I know, not much of an abbreviation, but that's where we're at. All right, so in terms of our molecules, our diatomic elements, they exist as molecules. And remember, our diatomic elements, sometimes we refer to them as those 7-Ups. Also, our molecular compounds. Molecular compounds exist as molecules. I guess that makes sense. And then the third type of compound that exists as molecules are our acids. So quick little review here. Remember, the molecular compounds are going to exist of all nonmetals, and our acids are going to start with hydrogen, except for water. All right, so if I had 1 mole of nitrogen, diatomic, that's why I have that subscript of 2 there. And that means I have 6.02 times 10 to the 23rd molecules. I'm going to use this abbreviation, guys, MQL, to represent molecule, just to shorten it up just a little bit. If I had 1 mole of CO2, carbon dioxide, I have 6.02 times 10 to the 23rd molecules of CO2. And if I had 1 mole of hydrochloric acid, guess what? 6.02 times 10 to the 23rd is the number of things I have. but it's going to be molecules of HCl. So as long as it is a diatomic element, a molecular substance, or an acid, we have 6.02 times 10 to the 23rd molecules of that substance, if, of course, I have 1 mole of it. So the only type of compound I haven't mentioned yet that we're familiar with is the ionic compound. Quick little review here. On the simplest level, it's going to exist of a metal cation and a non-metal anion. Sometimes polyatomic ions will replace one of those. And so an ionic compound, if I have a mole of it, it is going to exist as a formula unit. So if I have 1 mole of NaCl, I have 6.02 times 10 to the 23rd. Doesn't matter what I have. If I have a mole of it, it's 6.02 times 10 to the 23rd. And what I'm going to do is I'm going to call a formula unit an FMU, just as an abbreviation. Please, whatever you do not shorten that any more than that. Okay, so if I have 1 mole of anything, I have 6.02 times 10 to the 23rd of those anything. And I just need to know, I don't call it any of these chemical substances existing as particles. I need to know when it's appropriate to use atom versus molecule versus formula unit. Okay, so now what you need to do is you need to go to the mass video for the mole. See you on the flip side.